Picture this, a vast expanse of space where galaxies swirl like cosmic dancers, and yet, hidden within this celestial ballet lies a mystery that defies explanation. In the heart of the Leo cluster, a region teeming with stars, black holes, and galaxies, there are phenomena that even the brightest minds in science cannot fully understand. What if I told you that some of these mysteries could rewrite everything we know about the universe? From vanishing galaxies to black holes that whisper in rhythmic pulses, the Leo cluster holds secrets that challenge our very understanding of space and time. Today, we're diving into 25 of the most baffling, unexplained phenomena in this enigmatic corner of the cosmos. By the end of this journey, you'll not only witness the wonders of the Leo cluster, but also uncover questions that might leave you staring at the night sky, wondering what else is out there. So, are you ready to explore the unknown? Let's begin. Now, let's turn our attention to the first of these cosmic enigmas, the Phantom Galaxy. Nestled within the Leo cluster, this galaxy has baffled astronomers with its peculiar behavior. Imagine observing a galaxy one moment, only for it to seemingly vanish the next, as if it were playing a cosmic game of hide and seek. This erratic visibility has earned it the name Phantom Galaxy, and it's one of the most puzzling phenomena in the cluster. What could cause a galaxy to disappear and reappear? One leading theory points to the role of dark matter, the invisible substance that makes up a significant portion of the universe. Some scientists suggest that dense pockets of dark matter in the Leo cluster could be bending and distorting the light from the Phantom Galaxy, making it appear and disappear depending on how the light is redirected. This phenomenon, known as gravitational lensing, might explain why the galaxy seems to vanish at times, but there's more to this mystery. Another possibility is that the Phantom Galaxy is surrounded by vast clouds of interstellar dust which periodically obscure it from view. These clouds could be remnants of ancient cosmic collisions or the result of intense star formation, creating a veil that hides the galaxy from our telescopes. The implications of this phenomenon are profound. If dark matter is indeed responsible for the Phantom Galaxy's erratic visibility, it could provide new insights into the nature of this elusive substance. Understanding how dark matter interacts with light and matter on such a grand scale could help us unravel some of the universe's deepest secrets. As we continue to study the Phantom Galaxy, one thing is clear. It challenges our understanding of how galaxies behave and interact within the cosmos. What other mysteries might this ghostly galaxy hold? And what could it teach us about the hidden forces shaping our universe? The answers may lie just beyond the reach of our current knowledge, waiting to be discovered. Next, we'll explore another strange phenomenon in the Leo cluster, a supermassive black hole that whispers in rhythmic pulses. What could these mysterious signals mean? Let's find out. Now, let's journey deeper into the Leo cluster to uncover another cosmic mystery, the whispering black hole. This supermassive black hole has captured the attention of astronomers not for its destructive power, but for the strange, rhythmic radio signals it emits. Unlike the chaotic bursts typically associated with black holes, these signals are eerily consistent, almost like a cosmic heartbeat echoing through the void. What makes these signals so unusual is that they defy our current understanding of black hole behavior. According to astrophysical models, black holes are known for their immense gravitational pull, which swallows everything, including light. Yet, this black hole seems to be whispering in a way that challenges our expectations. The rhythmic pulses suggest a level of order and regularity that scientists are struggling to explain. One theory proposes that these signals could be caused by matter spiraling into the black hole in a highly organized manner. As gas and dust are pulled in, they might form a stable, rotating disk that emits periodic bursts of energy. Another possibility is that the black hole's magnetic field is interacting with its surroundings in a unique way, creating these rhythmic pulses. but the implications go even deeper. If these signals are indeed a result of organized matter or magnetic interactions, they could provide new insights into how black holes consume and influence their environments. This could help us better understand the role black holes play in shaping galaxies and the larger universe. The whispering black hole also raises questions about the nature of spacetime itself. Could these rhythmic signals hint at hidden structures or forces around black holes that we've yet to discover? Or might they point to entirely new physics that could reshape our understanding of the cosmos? As we continue to listen to these mysterious whispers, one thing is certain: this black hole is not just a silent devourer of light. It's a cosmic enigma, offering clues to the hidden workings of the universe. Next, we'll turn our gaze to another strange phenomenon in the Leo cluster, a region that glows faintly without any apparent source of light. What could be causing this eerie illumination? Let's find out. Now, let's shift our focus to a phenomenon that seems to defy the very nature of darkness in space, the glowing void. Nestled within the Leo cluster, this mysterious region emits a faint, eerie glow that has left astronomers scratching their heads. Unlike the bright stars and galaxies we're accustomed to seeing, this glow has no obvious source, making it one of the most puzzling features in the cosmos. What could be causing this faint illumination? One leading theory points to dark energy, the mysterious force driving the accelerated expansion of the universe. Some scientists speculate that interactions between dark energy and the surrounding space could produce this subtle glow. If true, this would be a groundbreaking discovery, offering a rare glimpse into the behavior of one of the universe's most elusive components. Another possibility is that the glow is the result of unknown cosmic phenomena. For instance, it could be caused by exotic particles or energy fields that we have yet to detect or understand. These particles might interact with the fabric of space itself, creating a faint light that permeates the void. There's also the intriguing idea that the glowing void could be a remnant of an ancient cosmic event. Perhaps it's the lingering echo of a long-forgotten supernova or the aftermath of a collision between galaxies. Over time, the energy from such an event could have spread out, creating this diffuse glow that we now observe. Whatever the cause, the glowing void challenges our understanding of what space should look like. It reminds us that even the darkest corners of the universe can hold secrets waiting to be uncovered. As we continue to study this enigmatic region, we may find clues that reshape our understanding of the cosmos. Next, we'll explore another astonishing phenomenon in the Leo cluster, a group of stars that move in perfect harmony, defying the chaotic nature of the universe. What could be behind this cosmic dance? Let's dive in. Now, let's turn our attention to a celestial spectacle that seems to defy the randomness of the cosmos, the dancing stars. Within the Leo cluster, there exists a group of stars that move in an inexplicably synchronized pattern, as if choreographed by some unseen cosmic hand. This mesmerizing phenomenon has left astronomers both baffled and fascinated, as it challenges our understanding of how stars behave in the vast expanse of space. What could be causing these stars to move in such perfect harmony? One compelling theory suggests the presence of gravitational anomalies. These anomalies could be the result of massive, unseen objects, like black holes or dark matter clusters exerting their influence on the stars. Imagine a hidden puppeteer pulling the strings of gravity to create this cosmic dance. If true, this would provide valuable insights into the distribution and behavior of dark matter, one of the universe's greatest mysteries. Another possibility is that the synchronized movement is due to a hidden force or interaction we have yet to discover. Some scientists speculate that exotic particles or energy fields, still unknown to us, might be at play. These forces could be subtly altering the gravitational dynamics of the region, causing the stars to move in unison. This idea opens the door to entirely new realms of physics, where the rules we know might not apply. There's also the intriguing notion that the dancing stars could be the result of a past cosmic event. Perhaps a collision or merger between galaxies in the Leo cluster created a unique gravitational environment, locking these stars into their synchronized motion. Over time, this pattern could have stabilized, creating the stunning display we observe today. Whatever the explanation, the dancing stars remind us that the universe is full of surprises. They challenge us to rethink what we know about gravity, motion, and the forces that shape the cosmos. As we continue to study this phenomenon, we may uncover clues that reveal not only the secrets of the Leo cluster, but also the deeper workings of the universe itself. Next, we'll explore another mind-bending mystery, a phenomenon where light from distant galaxies appears to echo in the Leo cluster. What could be causing this cosmic reverberation? Let's find out. Now, let's shift our gaze to a phenomenon that seems to bend the very fabric of reality, the cosmic echo. In the Leo cluster, astronomers have observed something extraordinary, light from distant galaxies appearing to echo, as if the cosmos itself is whispering back to us. This eerie repetition of light defies our current understanding of how light travels through space, raising questions about the nature of light propagation and the structure of the universe itself. So, what exactly is happening here? Normally, light travels in straight lines, or so we think. But in the Leo cluster, light from galaxies billions of light years away seems to bounce or repeat, creating what scientists call an echo. This isn't a literal echo like sound waves bouncing off a canyon wall, but rather a strange duplication or delay in the light we observe. It's as if the universe is playing a cosmic trick on us, showing us the same light more than once. One possible explanation lies in the concept of gravitational lensing. Massive objects like galaxy clusters can warp the fabric of space-time, bending the path of light as it travels through the universe. This bending can create multiple images of the same galaxy, or even delay the arrival of light, making it appear as though the light is echoing. However, the echoes observed in the Leo cluster don't fully align with traditional gravitational lensing models, leaving scientists scratching their heads. Another theory suggests that the echoes could be caused by an unusual distribution of dark matter. If dark matter is clumped in a specific way within the Leo cluster, it might create a kind of mirror effect, reflecting light in unexpected patterns. This would not only explain the echoes, but also provide new insights into the mysterious nature of dark matter itself. There's also the tantalizing possibility that we're witnessing a new kind of cosmic phenomenon altogether. Perhaps the echoes are the result of interactions between light and exotic particles or energy fields that we have yet to discover. This would open up entirely new avenues of research, challenging our fundamental understanding of physics and the behavior of light in space. The cosmic echo is more than just a scientific curiosity. It's a reminder that the universe is far stranger and more complex than we often assume. As we continue to study this phenomenon, we may uncover clues that reshape our understanding of light, space, and the very nature of reality. Next, we'll delve into another enigma, a mysterious barrier in the Leo cluster that seems to block the movement of galaxies. What could be creating this invisible wall? Let's explore. Now, let's turn our attention to a baffling structure that seems to defy the very laws of cosmic motion, the invisible wall. Deep within the Leo cluster, astronomers have detected a mysterious barrier that appears to halt the movement of entire galaxies. Imagine a force so powerful that it can stop galaxies in their tracks, as if an unseen hand is holding them back. This invisible wall is one of the most perplexing phenomena in the cluster, and it challenges our understanding of how galaxies interact and move through space. So, what could be causing this cosmic roadblock? One leading theory points to cosmic filaments, vast, thread-like structures made of dark matter and gas that stretch across the universe. These filaments form a kind of cosmic web connecting galaxies and clusters. In some cases, they might act like barriers, creating regions where galaxies cannot easily pass. If the Leo cluster's invisible wall is part of such a filament, it could explain why galaxies seem to pile up against it, unable to move forward. Another possibility is that this wall is the result of an unknown force or interaction within the cluster. Some scientists speculate that it could be tied to dark energy, the mysterious force driving the accelerated expansion of the universe. If dark energy behaves differently in certain regions, it might create areas of resistance, effectively forming walls that galaxies cannot cross. This would not only explain the barrier, but also provide new insights into the nature of dark energy itself. There's also the intriguing idea that the wall could be a remnant of an ancient cosmic event, such as a collision between galaxy clusters billions of years ago. Such collisions can leave behind shock waves or dense regions that act as barriers, trapping galaxies in place. If this is the case, the invisible wall could be a fossil from a dramatic moment in the Leo cluster's history, offering a glimpse into its turbulent past. The invisible wall is more than just a scientific puzzle. It's a reminder that the universe is filled with structures and forces we are only beginning to understand. As we study this phenomenon, we may uncover clues about the large-scale architecture of the cosmos and the hidden forces that shape it. Next, we'll explore a quasar in the Leo cluster that seems to warp time itself. What could be causing this bizarre effect? Let's find out. Now, let's journey into the realm of spacetime itself, where the rules of physics seem to bend in ways that challenge our understanding of the universe. Deep within the Leo cluster lies a quasar that doesn't just shine with incredible brightness, it appears to warp time itself. This phenomenon, known as the time-warping quasar, is one of the most mind-bending discoveries in modern astronomy, and it forces us to rethink what we know about the fabric of reality. At the heart of this mystery is a quasar, a supermassive black hole surrounded by a swirling disk of gas and dust, emitting enormous amounts of energy. But what sets this quasar apart is its bizarre effect on time. Observations suggest that time near this quasar appears to slow down dramatically, as if the universe itself is hitting the brakes. This isn't science fiction, it's a real-world example of how extreme gravity can distort spacetime, just as Einstein predicted in his theory of general relativity. According to Einstein, massive objects like black holes can warp the fabric of spacetime, creating what we perceive as gravity. The stronger the gravitational pull, the more spacetime bends and the slower time moves. Near the time-warping quasar, the gravitational field is so intense that it stretches time to a crawl. Imagine watching a clock near this quasar. It would tick far slower than a clock here on Earth. This effect, known as gravitational time dilation, is a direct consequence of Einstein's theory, but the scale at which it's happening here is unprecedented. So, what does this mean for our understanding of the universe? For one, it provides a stunning confirmation of Einstein's predictions, showing that his ideas about spacetime hold true even in the most extreme environments. But it also raises new questions. Why does this quasar exhibit such an extreme time-warping effect compared to others? Could there be something unique about its structure or the way it interacts with its surroundings? Some scientists speculate that the quasar might be surrounded by an unusually dense concentration of dark matter, amplifying its gravitational influence. Others suggest that it could be the result of a rare alignment of cosmic forces, creating a perfect storm for time dilation. The time-warping quasar isn't just a scientific curiosity, it's a window into the fundamental nature of reality. By studying this phenomenon, we can gain deeper insights into how gravity, space-time, and time itself are interconnected. It challenges us to think beyond our everyday experience and consider the universe as a dynamic, ever-changing tapestry where the rules we take for granted can be rewritten. As we continue to unravel the mysteries of the Leo cluster, our next stop takes us to a ghostly nebula that defies conventional detection. What secrets does this invisible structure hold? Let's find out. Now, shifting our gaze to another enigmatic feature of the Leo cluster, we encounter a phenomenon that challenges our very perception of the cosmos. Meet the ghostly nebula, a cosmic structure that remains invisible to the naked eye yet reveals its presence through wavelengths beyond the spectrum of visible light. This mysterious nebula, detected through infrared and radio observations, defies conventional understanding and opens up a new frontier in our exploration of the universe. Unlike typical nebulae, which glow with vibrant colors as they reflect or emit light, the ghostly nebula emits no visible light at all. Instead, it is detected through its faint signals in other parts of the electromagnetic spectrum. This raises a fascinating question. What exactly is this nebula made of, and why does it remain hidden from our traditional telescopes? Scientists believe it could be composed of cold, dense gas and dust, so thick that it absorbs all visible light passing through it. Yet, its presence is betrayed by the faint whispers of infrared radiation and radio waves, which pierce through the darkness to reveal its hidden form. The discovery of the ghostly nebula has profound implications for our understanding of cosmic structures. It suggests that there may be entire regions of space filled with similar invisible formations, lurking undetected in the vast expanse of the universe. These structures could play a crucial role in the formation of stars and galaxies, acting as hidden reservoirs of material that fuel the birth of new celestial bodies. If this is the case, then our current maps of the universe might be missing significant pieces of the puzzle, with entire networks of dark nebulae waiting to be uncovered. One leading theory proposes that the ghostly nebula could be a cosmic nursery, a place where stars are born in the shadows, shielded from the prying eyes of visible light telescopes. The dense clouds of gas and dust within the nebula might collapse under their own gravity, igniting the process of star formation. Yet, because this process occurs in near total darkness, it remains one of the most elusive and least understood aspects of astrophysics. Another intriguing possibility is that the ghostly nebula could be a remnant of an ancient supernova, a relic from a star that exploded long ago. The remnants of such an explosion could have left behind a dense cloud of material, now invisible to us but detectable through its faint emissions. If true, this would provide a rare glimpse into the aftermath of stellar death and the recycling of matter in the universe. The ghostly nebula reminds us that the universe is far more complex and mysterious than we often assume. It challenges us to look beyond what we can see and to explore the hidden layers of reality that lie just beyond our perception. As we continue to study this enigmatic structure, we may uncover new insights into the birth and evolution of stars, the distribution of matter in the cosmos, and the forces that shape the universe on the grandest scales. With this ghostly mystery still lingering in our minds, our journey through the Leo cluster takes us next to a group of rogue planets that defy all expectations. What could these wandering worlds tell us about the chaotic nature of the cosmos? Let's find out. Now, as we venture deeper into the mysteries of the Leo cluster, we stumble upon a group of celestial wanderers that defy the very rules of planetary formation. These are the rogue planets, worlds untethered from any star, drifting freely through the cold, dark expanse of space. Unlike the planets in our solar system, which orbit the sun in predictable paths, these rogue planets are nomads traveling alone through the cosmos. But how did they end up here, and what can they tell us about the chaotic nature of the universe? Rogue planets, also known as free-floating planets, are not bound by the gravitational pull of a star. Instead, they roam the galaxy independently, often invisible to traditional telescopes because they emit no light of their own. The discovery of a cluster of these rogue planets in the Leo cluster has left scientists baffled. According to our current understanding of planetary formation, planets are born from the swirling disks of gas and dust that surround young stars. So how did these planets break free from their stellar nurseries and end up adrift in space? One leading theory suggests that these rogue planets were once part of a star system, but were violently ejected due to gravitational interactions. Imagine a cosmic game of billiards where the gravitational pull of massive planets or passing stars can fling smaller worlds out of their orbits, sending them hurtling into the void. This chaotic process could explain why we find so many rogue planets clustered together in the Leo cluster, a region of space where gravitational forces are particularly intense. Another possibility is that these planets formed on their own without the need for a star. In the dense clouds of gas and dust that permeate the Leo cluster, pockets of material could collapse under their own gravity, forming planets directly. These failed stars, as some scientists call them, never gathered enough mass to ignite nuclear fusion and become stars, but they still managed to form as independent planetary bodies. If this is the case, it would challenge our traditional models of planetary formation and open up new avenues for understanding how planets come into existence. The presence of rogue planets in the Leo cluster also raises intriguing questions about the potential for life in the universe. While these planets lack the warmth and light of a star, some scientists speculate that they could harbor subsurface oceans, kept liquid by internal heat or tidal forces. If life could exist in such extreme environments, it would expand our understanding of where life might thrive beyond Earth. As we ponder the origins and fates of these rogue planets, we are reminded once again of the dynamic and unpredictable nature of the cosmos. These wandering worlds challenge our assumptions and invite us to rethink the processes that shape planetary systems. With each discovery, we uncover new layers of complexity in the universe, pushing the boundaries of our knowledge and sparking new questions. And speaking of cosmic mysteries, our journey through the Leo cluster now takes us to a star that defies the very laws of stellar evolution. What could explain a star that has been burning far longer than it should? Let's explore this next enigma together. As we continue our exploration of the Leo cluster, we encounter a phenomenon that defies one of the most dramatic events in the cosmos, a supernova that went off in silence. Supernovas are typically the explosive finales of massive stars, lighting up the universe with bursts of energy and radiation that can outshine entire galaxies. But in the Leo cluster, astronomers have observed a supernova that broke the rules, exploding without the expected fanfare of light and radiation. This silent supernova challenges our understanding of how stars end their lives and raises profound questions about the hidden mechanisms of stellar death. When a massive star exhausts its nuclear fuel, its core collapses under its own gravity, triggering a cataclysmic explosion. This explosion releases an immense amount of energy, including visible light, X-rays, and gamma rays, which can be detected across vast distances. However, the supernova in the Leo cluster was different. Despite the telltale signs of a stellar explosion such as shock waves and the dispersal of heavy elements, the expected radiation was conspicuously absent. This anomaly has left scientists puzzled, prompting them to reconsider the processes that govern supernovas. One possible explanation for this silent supernova is the presence of an unusually dense cloud of material surrounding the star before its explosion. As the star collapsed and exploded, the energy released might have been absorbed by this surrounding material, effectively muffling the blast. This would explain why the supernova appeared dimmer and quieter than expected. Another theory suggests that the star may have collapsed directly into a black hole, bypassing the typical supernova stage altogether. In this scenario, the star's core would have imploded so rapidly that the explosion's energy was trapped, leaving little to no visible trace. The implications of this silent supernova are far-reaching. If stars can explode without the expected radiation, it could mean that many supernovas have gone unnoticed, hidden from our telescopes. This would significantly impact our estimates of how often stars explode and how they contribute to the chemical enrichment of the universe. Additionally, the discovery challenges our understanding of the life cycles of stars, suggesting that there may be multiple pathways for stellar death that we have yet to uncover. This phenomenon also highlights the importance of studying the Leo cluster, a region of space that continues to surprise us with its mysteries. Each discovery, like this silent supernova, pushes the boundaries of our knowledge and forces us to rethink what we thought we knew about the universe. As we piece together the clues left behind by these cosmic events, we gain a deeper appreciation for the complexity and diversity of stellar evolution. Now, as we turn our attention to the next mystery in the Leo cluster, we find ourselves confronted with a region of space where the rules of magnetism seem to have gone haywire. What could cause such a powerful and erratic magnetic field? Let's dive into this magnetic anomaly and uncover the secrets it holds. Moving deeper into the mysteries of the Leo cluster, we now encounter a phenomenon that twists the very fabric of space itself, a magnetic anomaly unlike anything astronomers have ever seen. In this region of the cluster, the magnetic field is not only extraordinarily powerful, but also behaves in ways that defy our current understanding of physics. Imagine a cosmic storm where the rules of magnetism are rewritten, creating a chaotic and unpredictable environment that challenges everything we know about magnetic fields in space. Magnetic fields are a fundamental part of the universe, shaping the behavior of stars, galaxies, and even entire clusters. They influence how matter moves, how energy is transferred, and how cosmic structures evolve over time. But in this particular region of the Leo cluster, the magnetic field is so intense and erratic that it has left scientists scratching their heads. Measurements show that the field's strength fluctuates wildly, sometimes spiking to levels far beyond what should be possible in such a vast and diffuse region of space. What could be causing this bizarre behavior? One leading theory suggests that the anomaly might be the result of a collision between two massive galaxy clusters. When these colossal structures collide, they can generate shock waves that ripple through the surrounding space, potentially amplifying magnetic fields to extreme levels. The chaotic aftermath of such a collision could explain why the magnetic field in this region is so unstable and unpredictable. Another possibility is that the anomaly is fueled by the presence of a hidden supermassive black hole, whose immense gravitational pull could be distorting the magnetic field in ways we don't yet fully understand. The effects of this magnetic anomaly on nearby celestial bodies are equally fascinating and potentially disruptive. Stars, gas clouds, and even entire galaxies in the vicinity could be influenced by the erratic magnetic forces, altering their trajectories and even their internal structures. For example, the intense magnetic field might accelerate charged particles to incredible speeds, creating jets of energy that shoot out into space. These jets could, in turn, heat up surrounding gas clouds, triggering the formation of new stars or disrupting existing ones. The anomaly might also play a role in shaping the large-scale structure of the Leo cluster itself, influencing how galaxies move and interact over billions of years. This magnetic anomaly not only challenges our understanding of how magnetic fields operate in space, but also raises intriguing questions about the forces that shape the cosmos. Could similar anomalies exist elsewhere in the universe, hidden from our view? And what might they tell us about the fundamental laws of physics? As we continue to study this enigmatic region, we are reminded once again of the Leo cluster's ability to surprise and inspire, offering us glimpses into the profound mysteries that lie at the heart of the universe. As we shift our focus to the next phenomenon, we find ourselves staring into a cosmic illusion, a distortion of light and space that makes distant galaxies appear as if they are shifting positions. What could be causing this strange effect? Let's unravel the mystery of the cosmic mirage. Now, let's turn our attention to a phenomenon that plays tricks on our eyes and our instruments, the cosmic mirage. In the Leo cluster, distant galaxies sometimes appear distorted, stretched, or even duplicated, as if space itself is bending light in ways that defy explanation. While gravitational lensing, a well-known effect where massive objects warp the fabric of space-time, can explain some of these distortions, what we're seeing here goes beyond the usual lensing effects. This cosmic mirage challenges our understanding of how light travels through the universe and raises questions about what might be causing these extraordinary visual anomalies. Gravitational lensing occurs when a massive object, like a galaxy or a cluster of galaxies, lies between us and a more distant object. The immense gravity of the foreground object bends the light from the background object, creating effects like magnification, distortion, or even multiple images of the same galaxy. In the Leo cluster, however, some of these distortions are far more extreme than what gravitational lensing alone should produce. Galaxies appear not just stretched or magnified, but sometimes duplicated in ways that don't align with the predicted patterns of lensing. This has led scientists to wonder if there's something else at play, something hidden or unknown that's amplifying or altering the lensing effect. One possibility is that the Leo cluster contains an unusually dense concentration of dark matter, the mysterious substance that makes up most of the universe's mass but doesn't emit light. Dark matter's gravitational influence could be enhancing the lensing effect, creating distortions that are more pronounced than what we'd expect from visible matter alone. Another intriguing idea is that the cluster might be home to structures or objects we can't yet detect. Perhaps cosmic strings, hypothetical one-dimensional defects in space-time, or even exotic forms of matter that interact with light in strange ways. These hidden elements could be bending light in unexpected patterns, creating the cosmic mirage we observe. The implications of this phenomenon are profound. If the distortions in the Leo cluster can't be fully explained by gravitational lensing, it could mean that our understanding of gravity, dark matter, or even the nature of spacetime itself is incomplete. It might also suggest that the universe contains structures or forces we haven't yet discovered, waiting to be revealed by further study. The cosmic mirage serves as a reminder that even the most well-understood phenomena in space can still hold surprises, challenging us to rethink what we know about the cosmos. As we move forward, we'll explore another mystery in the Leo cluster: stars that vanish without a trace. What could cause entire stars to disappear, leaving no evidence behind? The answer might lie in the hidden forces that shape the universe. Now, let's shift our gaze to a phenomenon that feels almost like magic: stars that vanish without a trace. In the Leo cluster, astronomers have observed stars that simply disappear, leaving behind no remnants, no explosions, and no clues as to what happened. It's as if they were erased from the cosmic canvas, and this mystery has left scientists scratching their heads. One of the leading theories involves black holes. These cosmic vacuum cleaners are known for their ability to swallow anything that comes too close, including light itself. If a star were to wander too close to a black hole, it could be torn apart in a process called spaghettification, where the star is stretched into thin strands before being consumed. However, this process usually leaves behind some evidence, like bursts of radiation or gravitational waves. In the case of the vanishing stars in the Leo cluster, there's no such trace, which makes this explanation incomplete. Another possibility is dark matter, the invisible substance that makes up most of the universe's mass. While dark matter doesn't interact with light, its gravitational pull could influence stars in ways we don't fully understand. Some scientists speculate that dense clumps of dark matter might exist in the Leo cluster, capable of capturing or disrupting stars without leaving any visible signs. This idea is still speculative, but it opens up fascinating questions about the hidden forces at work in the universe. There's also the chance that these stars didn't vanish but instead transformed into something else. For example, a star could collapse into a neutron star or a black hole without the dramatic explosion of a supernova. This quiet collapse would leave little to no observable evidence, making it seem as though the star simply disappeared. While this theory fits some observations, it doesn't explain all the cases of vanishing stars in the Leo cluster, leaving room for further investigation. The implications of these vanishing stars are profound. If stars can disappear without a trace, it challenges our understanding of stellar life cycles and the mechanisms that govern the universe. It also raises questions about what else might be lurking in the cosmos, unseen and undetected. Are there other forces or phenomena at play that we haven't yet discovered? The Leo cluster continues to be a treasure trove of mysteries, pushing the boundaries of our knowledge. As we move forward, we'll explore another enigma in this fascinating region of space, a star that defies the laws of time by burning far longer than it should. What could be keeping this eternal flame alive? The answer might reveal even more about the strange and wondrous nature of the universe. Now, let's turn our attention to a star that seems to defy the very laws of time itself, a celestial anomaly known as the Eternal Flame. Nestled within the Leo cluster, this star has been burning for far longer than any model of stellar evolution predicts. Stars, like all cosmic objects, have lifespans dictated by their size, composition, and the fuel they consume. But this star is breaking all the rules, and its persistence is challenging everything we thought we knew about how stars live and die. At the heart of this mystery is the star's fuel source. Stars typically burn hydrogen in their cores, converting it into helium through nuclear fusion. Over time, as the hydrogen depletes, the star evolves, often expanding into a red giant before ending its life in a dramatic supernova or fading into a white dwarf. But the eternal flame appears to have found a way to sustain itself far beyond this expected timeline. Some scientists suggest that it might be tapping into an unconventional energy source, such as helium or even heavier elements, to keep its fires burning. This would require a unique set of conditions, possibly involving interactions with nearby celestial bodies or an unusually dense core. Another intriguing possibility is that this star is part of a binary system where two stars orbit each other closely. In such systems, one star can sometimes transfer material to its companion, effectively refueling it and extending its lifespan. If the eternal flame is receiving a steady supply of material from a neighboring star, it could explain why it continues to shine long after it should have exhausted its fuel. However, observations so far have not confirmed the presence of a companion star, leaving this theory in the realm of speculation. The implications of this phenomenon are profound. If stars can burn longer than predicted, it could mean that our understanding of stellar evolution is incomplete. Perhaps there are unknown processes or exotic forms of matter at play, influencing how stars age and die. This could also have implications for the broader universe, as stars are the building blocks of galaxies and the source of many elements essential for life. If stars like the Eternal Flame exist elsewhere, they could be altering the cosmic timeline in ways we're only beginning to grasp. As we continue to study this enigmatic star, one thing is clear. The Leo cluster is a place where the universe's most puzzling secrets are waiting to be uncovered. And with each discovery, we're reminded that the cosmos is far more complex and mysterious than we ever imagined. Next, we'll delve into another astonishing phenomenon, a galaxy that seems to cast a shadow on the fabric of space itself. What could be causing this eerie effect? The answer might just redefine our understanding of light, matter, and the very nature of the universe. Now, let's shift our gaze to a phenomenon that seems to defy the very nature of light itself, a galaxy in the Leo cluster that casts an eerie shadow across the cosmos. Known as the Shadow Galaxy, this mysterious structure appears to darken the space around it, as if it's blocking out the light from distant stars and galaxies. But how can a galaxy, which is itself a source of light, create such a shadow? The answer might lie in the invisible forces that shape our universe. One leading theory suggests that the shadow galaxy's effect could be tied to dark matter, the elusive substance that makes up a significant portion of the universe's mass. Dark matter doesn't emit, absorb, or reflect light, making it invisible to our telescopes. However, its gravitational influence can bend and distort light, a phenomenon known as gravitational lensing. If the shadow galaxy is surrounded by an unusually dense concentration of dark matter, it could be bending light in such a way that it creates the illusion of a shadow. This would mean that the galaxy isn't blocking light directly, but rather warping the path of light from objects behind it, creating a dark patch in the sky. Another possibility is that the shadow galaxy is interacting with an unseen cosmic structure, such as a massive cloud of gas or dust. These materials can absorb or scatter light, effectively dimming the brightness of objects behind them. If such a cloud lies between the shadow galaxy and our line of sight, it could explain the shadowy effect. However, observations have yet to detect any significant amounts of gas or dust in the region, leaving this theory as a tantalizing but unproven idea. Some scientists have even proposed that the shadow galaxy might be the result of an entirely new cosmic phenomenon, one that we don't yet understand. Could there be exotic forms of matter or energy at play, interacting with light in ways that challenge our current understanding of physics? The shadow galaxy might be a clue to uncovering these hidden forces, offering a glimpse into the deeper mysteries of the universe. The implications of this phenomenon are profound. If the shadow galaxy is indeed interacting with dark matter or other unknown forces, it could provide crucial insights into the nature of these elusive components of the cosmos. Understanding how light behaves in such extreme environments could also help us refine our models of the universe's structure and evolution. And as we continue to study this enigmatic galaxy, we're reminded once again that the Leo cluster is a treasure trove of cosmic mysteries, each one pushing the boundaries of our knowledge. As we move forward, we'll explore yet another astonishing phenomenon, a group of galaxies that pulsate in unison, as if dancing to the rhythm of the cosmos. What could be causing this synchronized behavior, and what does it reveal about the forces that bind the universe together? The answers might just reshape our understanding of the cosmos. Now, let's turn our attention to a phenomenon that seems to dance to the rhythm of the cosmos itself. A group of galaxies in the Leo cluster that pulsate in perfect unison. This synchronized behavior, known as the pulsating cluster, is unlike anything we've observed before. Imagine galaxies, vast and ancient, moving together as if choreographed by some unseen cosmic force. But what could possibly cause such a coordinated display on such an enormous scale? One compelling theory points to the influence of dark energy, the mysterious force driving the accelerated expansion of the universe. Dark energy is thought to permeate all of space, exerting a subtle but pervasive pressure. In regions where dark energy is particularly concentrated, it could create ripples or waves that affect the motion of galaxies. If the galaxies in this cluster are responding to these ripples, it might explain why they appear to pulsate in harmony. This would suggest that dark energy isn't just a passive backdrop, but an active participant in shaping the behavior of cosmic structures. Another possibility involves the gravitational interactions between the galaxies themselves. Galaxies in clusters are often bound together by their mutual gravitational pull, creating a delicate balance of forces. If one galaxy moves, it can influence the others, setting off a chain reaction. In the case of the pulsating cluster, this interplay might have reached a state of resonance where the galaxies' movements amplify each other, resulting in a synchronized pulsation. Think of it like a group of pendulums swinging in perfect time. Once they're in sync, they stay that way. Some researchers have even speculated that the pulsations could be linked to the presence of a supermassive black hole at the cluster's center. Black holes are known to generate powerful gravitational waves, which can ripple through space and affect nearby objects. If the galaxies in this cluster are responding to these waves, it could create the appearance of synchronized pulsations. This would not only deepen our understanding of black holes, but also reveal how their influence extends far beyond their immediate surroundings. The implications of the pulsating cluster are profound. If dark energy, gravitational resonance, or black hole activity is indeed responsible, it could provide new insights into the forces that govern the universe. Understanding this phenomenon might also help us refine our models of galaxy formation and evolution, shedding light on how cosmic structures grow and change over time. And as we continue to study this mesmerizing cluster, we're reminded once again that the Leo cluster is a place where the ordinary becomes extraordinary and the familiar gives way to the fantastical. As we move forward, we'll explore another cosmic marvel, a region in the Leo cluster where galaxies seem to spiral into an unseen center, as if drawn by an invisible whirlpool. What could be pulling them in, and what secrets lie at the heart of this cosmic dance? The answers might just redefine our understanding of gravity itself. Now, let's dive into a phenomenon that feels like something out of a cosmic thriller, a region in the Leo cluster where galaxies seem to spiral into an unseen center, as if caught in the grip of an invisible whirlpool. This mesmerizing display, known as the cosmic whirlpool, raises questions about what could be pulling these galaxies into such a dramatic dance. Could it be the work of a hidden supermassive black hole, or perhaps something even more mysterious? One leading theory suggests that a supermassive black hole lurking at the heart of this region is the driving force behind the whirlpool effect. Black holes are known for their immense gravitational pull, capable of bending space and time around them. If a black hole of extraordinary size and power resides here, it could be drawing in nearby galaxies, causing them to spiral inward. This would not only explain the whirlpool-like motion, but also hint at the presence of a black hole far more massive than any we've encountered before. Such a discovery would challenge our understanding of how black holes form and grow. Another possibility is that this phenomenon is the result of a gravitational anomaly, a distortion in the fabric of space-time caused by an unseen concentration of mass. In the Leo cluster, where dark matter is thought to be abundant, such anomalies could arise from dense pockets of this elusive substance. Dark matter doesn't emit light, making it invisible to our telescopes, but its gravitational effects are undeniable. If a particularly dense clump of dark matter exists in this region, it could be warping space in a way that creates the illusion of a cosmic whirlpool, pulling galaxies into its gravitational embrace. Some scientists have even proposed that the cosmic whirlpool could be evidence of a cosmic string, a hypothetical, one-dimensional defect in space-time left over from the early universe. These strings, if they exist, will be incredibly dense and could exert immense gravitational forces. If a cosmic string were to pass through the Leo cluster, it might twist space-time in such a way that galaxies appear to spiral around it. While this idea remains speculative, it opens up fascinating possibilities about the nature of space-time itself. The implications of the cosmic whirlpool are as profound as they are puzzling. If a supermassive black hole is indeed at the center, it could provide new insights into the role these enigmatic objects play in shaping the universe. If dark matter or cosmic strings are responsible, it could revolutionize our understanding of gravity and the fundamental forces that govern the cosmos. Whatever the cause, this phenomenon reminds us that the Leo cluster is a place where the boundaries of our knowledge are constantly being tested. As we continue our journey through the Leo cluster, we'll explore another mystery, a region where light from distant stars appears to freeze in place, defying our understanding of time and space. What could cause such a strange phenomenon, and what does it reveal about the nature of the universe? The answers might just challenge everything we think we know. Now, let's turn our attention to a phenomenon that seems to defy the very laws of physics: light from distant stars in the Leo cluster that appears to freeze in place. This eerie effect, known as the frozen light, is as baffling as it is mesmerizing. Imagine looking at a star only to see its light suspended in time, unmoving, as if the universe itself has hit pause. What could possibly cause such a strange occurrence, and what does it mean for our understanding of light and time? At the heart of this mystery lies the behavior of light itself. Light as we know it travels at a constant speed, the fastest speed possible in the universe. Yet, in this region of the Leo cluster, something seems to be altering its journey. One theory suggests that extreme gravitational forces could be at play. In areas where gravity is incredibly strong, such as near massive black holes or dense clusters of dark matter, light can be bent and slowed down. This effect, known as gravitational time dilation, could make light appear to freeze as it struggles to escape the intense pull of gravity. If this is the case, the frozen light phenomenon might be a cosmic magnifying glass, revealing the presence of an unseen, incredibly massive object. Another possibility is that we're witnessing the effects of space-time itself being warped on a colossal scale. According to Einstein's theory of relativity, massive objects can curve spacetime, altering the path of light. In the Leo cluster, where galaxies and dark matter are densely packed, spacetime could be so distorted that light takes an unusually long time to travel through it. From our perspective, this could make the light appear frozen, as if time itself has slowed to a crawl. This would not only challenge our understanding of light, but also push the boundaries of how we perceive time in the universe. Some scientists have even speculated that the frozen light could be evidence of a cosmic anomaly, a region where the fabric of spacetime behaves in ways we've never observed before. Could this be a glimpse into a new kind of physics, one that operates beyond the rules we currently understand? If so, the Leo cluster might be hiding clues to a deeper truth about the nature of reality, waiting to be uncovered. The implications of the frozen light are profound. If light can be slowed or seemingly stopped, it raises questions about the fundamental nature of time and space. Could time itself be more fluid than we've imagined? And what does this mean for our understanding of the universe's structure? These are the kinds of questions that keep astronomers and physicists awake at night, and the Leo cluster continues to be a treasure trove of mysteries that challenge our most basic assumptions. As we move forward, we'll explore yet another enigma in the Leo cluster, a region where stars emit harmonic frequencies, creating what some have called a celestial symphony. What could cause such a phenomenon, and what does it reveal about the physics of sound in the vast emptiness of space? The answers might just change the way we listen to the universe. Now, let's shift our focus to a phenomenon that turns the silence of space into a cosmic concert, the celestial symphony. In a specific region of the Leo cluster, stars are emitting harmonic frequencies, creating a pattern of sound that defies our expectations of the vacuum of space. But how can sound exist in an environment where there's no air to carry it? And what does this tell us about the hidden physics of the universe? Sound, as we know it, requires a medium like air or water to travel. In the emptiness of space, where there's no atmosphere, traditional sound waves can't propagate. However, the celestial symphony isn't about sound as we hear it on Earth. Instead, it's about vibrations and frequencies that manifest in other forms. These harmonic frequencies are detected through electromagnetic waves, such as radio signals, which can travel through the vacuum of space. When these signals are translated into sound, they reveal a mesmerizing pattern, a symphony of stars. One theory suggests that these harmonic frequencies are the result of stellar vibrations. Stars, much like musical instruments, can oscillate or vibrate at specific frequencies. These vibrations are caused by internal processes, such as nuclear reactions or the movement of plasma within the star. When multiple stars vibrate in harmony, their frequencies can align, creating a coordinated pattern that resembles a musical composition. This phenomenon, known as stellar seismology, allows astronomers to listen to the stars and learn about their internal structures and behaviors. Another intriguing possibility is that these harmonic frequencies are influenced by the gravitational interactions between stars and other celestial bodies. In the densely packed Leo cluster, stars are often in close proximity, creating complex gravitational dances. These interactions could cause stars to resonate with one another, amplifying certain frequencies and creating a synchronized cosmic melody. This would not only provide insights into the dynamics of star clusters, but also reveal how gravity can orchestrate the movements of celestial bodies on a grand scale. The celestial symphony also raises questions about the nature of sound in space. While we can't hear these frequencies directly, their existence challenges our understanding of how energy and vibrations operate in the cosmos. Could these harmonic patterns be a form of communication between stars, or are they simply a byproduct of their natural processes? Either way, they offer a unique window into the physics of sound and vibration in environments far removed from our own. As we continue to explore the Leo cluster, the celestial symphony reminds us that the universe is full of surprises, even in the places we least expect. It's a reminder that space isn't just a silent void. It's a dynamic, ever-changing arena where even the stars can sing. Next, we'll delve into another mystery, a galaxy in the Leo cluster that remains invisible, detectable only through its gravitational effects. What secrets does this hidden galaxy hold, and how does it challenge our understanding of the cosmos? The answers might just redefine what we think we know about the universe. Now, let's turn our attention to a phenomenon that challenges our very ability to see the universe, the invisible galaxy. Hidden within the Leo cluster, this mysterious galaxy defies detection through traditional means. It doesn't emit light, nor does it reflect it. Instead, its presence is revealed only through its gravitational effects on the surrounding cosmos. But how can a galaxy exist without being seen? And what does this tell us about the hidden fabric of the universe? The invisible galaxy is a prime example of how much of the universe remains unseen. Unlike most galaxies which shine brightly with stars, gas, and dust, this one is cloaked in darkness. Astronomers first noticed its existence when they observed the gravitational pull it exerted on nearby galaxies and light. This phenomenon, known as gravitational lensing, occurs when the immense gravity of an object bends the light from objects behind it, creating distortions or magnifications. In this case, the invisible galaxy's gravity was bending the light from more distant galaxies, revealing its presence without ever showing itself directly. One leading theory suggests that this galaxy is composed almost entirely of dark matter. Dark matter is a mysterious substance that doesn't interact with light, making it invisible to our telescopes. Yet, it exerts a powerful gravitational influence, shaping the structure of the universe on the largest scales. If the invisible galaxy is indeed dominated by dark matter, it could provide crucial insights into how this elusive substance behaves and how it contributes to the formation and evolution of galaxies. Another possibility is that this galaxy is surrounded by an unusual cosmic structure, such as a dense cloud of gas or dust that blocks all visible light. While this would make it invisible to optical telescopes, other instruments like radio or infrared telescopes might eventually detect it. However, so far, no such signals have been found, deepening the mystery of what this galaxy truly is. The existence of the invisible galaxy also raises questions about how many other hidden galaxies might be lurking in the universe. If dark matter is as abundant as scientists believe, there could be countless galaxies like this one, invisible to our eyes but shaping the cosmos in profound ways. This challenges our understanding of the universe's structure and forces us to rethink how we map and study the vast expanse of space. As we continue to explore the Leo cluster, the invisible galaxy serves as a humbling reminder of how much we still have to learn. It's a testament to the fact that the universe is far more complex and mysterious than we can imagine. Next, we'll uncover another enigma, a mysterious network of filaments connecting galaxies in the Leo cluster. What role does this cosmic web play in the universe, and how does it shape the destiny of galaxies? The answers might just change the way we see the cosmos. Now, let's unravel another cosmic mystery that binds the universe together, the cosmic web. Imagine the Leo cluster as a bustling city with galaxies acting as neighborhoods. But what connects these neighborhoods? A vast, intricate network of filaments invisible to the naked eye, yet holding the universe in its grasp. This cosmic web is not just a random arrangement. It's the scaffolding upon which galaxies are built, shaping the very structure of the cosmos. The cosmic web is made up of long, thread-like structures of gas and dark matter stretching across unimaginable distances. These filaments act like cosmic highways, guiding galaxies into clusters and superclusters. But how does this web form? Scientists believe it's a result of the universe's earliest moments, when tiny fluctuations in density after the Big Bang grew over billions of years, pulling matter into these vast, interconnected strands. The Leo cluster, with its dense collection of galaxies, is a perfect example of how this web influences the distribution of matter on the largest scales. One of the most fascinating aspects of the cosmic web is its role in galaxy formation. Galaxies aren't scattered randomly, they're born and grow along these filaments like pearls on a string. The gas flowing through these threads provides the raw material for stars and galaxies to form. Without this network, the universe as we know it might look entirely different, sparse, disconnected, and devoid of the vibrant cosmic communities we see today. But the cosmic web isn't just about structure, it's also a key player in the universe's evolution. The filaments channel gas and energy between galaxies, fueling star formation and even influencing the growth of supermassive black holes. They also act as cosmic bridges, allowing galaxies to interact and merge, shaping their destinies over billions of years. In the Leo cluster, this web is particularly dense, creating a dynamic environment where galaxies are constantly evolving. The discovery of the cosmic web has profound implications for our understanding of the universe. It reveals that the cosmos is not a chaotic void but an organized, interconnected system. By studying these filaments, astronomers can trace the history of the universe from its earliest moments to the present day. It's like uncovering the blueprint of creation, showing us how the universe grew from a hot, dense soup of particles into the vast, structured expanse we see today. As we peer deeper into the Leo cluster, the cosmic web reminds us that the universe is more than just stars and galaxies. It's a living, breathing network, constantly shaping and reshaping itself. Next, we'll explore a region within the cluster that defies expectations, a place where stars are conspicuously absent. What could create such a starless void, and what does it tell us about the universe's hidden forces? The answers might just redefine our understanding of cosmic emptiness. Now, let's turn our attention to a phenomenon that challenges our understanding of cosmic emptiness, the starless void. Nestled within the Leo cluster, this vast region stands out for one striking reason. It's completely devoid of stars, no twinkling lights, no glowing galaxies, just an eerie, dark expanse that seems to defy the very nature of the universe. How can such a place exist, and what forces are at play here? The starless void isn't just an empty patch of space. It's a cosmic anomaly that has puzzled astronomers for years. Unlike typical voids, which are large, sparse regions between galaxy clusters, this void is unusually dense with gas and dark matter, yet it lacks any visible stars. This contradiction raises questions about the processes that govern star formation and the distribution of matter in the universe. Could this void be the result of some cosmic event that swept away all stars, or is it a region where star formation was somehow suppressed? One theory suggests that the starless void might be the aftermath of a colossal collision between galaxies. When galaxies collide, they can trigger massive bursts of star formation, but they can also strip away gas and dust, leaving behind barren regions. In this case, the collision might have been so violent that it disrupted the conditions needed for stars to form, creating this starless expanse. Another possibility is that the void is influenced by dark energy, the mysterious force driving the universe's expansion. Dark energy could be pushing matter apart in this region, preventing stars from forming and leaving behind a dark, empty space. but the starless void might also hold clues about the nature of cosmic voids themselves. These voids are not just empty spaces, they play a crucial role in the universe's large-scale structure. They act as counterpoints to the dense galaxy clusters, creating a cosmic balance. The starless void, with its unique properties, could help us understand how voids form and evolve over time. It might even reveal new insights into the interplay between dark matter, dark energy, and the visible universe. As we explore this enigmatic region, one thing becomes clear: the starless void is more than just an absence of stars. It's a window into the hidden forces that shape our universe. By studying this void, astronomers hope to uncover the secrets of cosmic emptiness and the processes that govern the birth and death of stars. What other mysteries lie hidden in the darkness, waiting to be discovered? The answers could reshape our understanding of the cosmos. Next, we'll delve into another mind-bending phenomenon, a quasar that appears to defy the very fabric of time. What could cause light from different time periods to converge in a single point in space? The implications are as profound as they are puzzling. Now, let's shift our gaze to a phenomenon that seems to bend the very rules of time itself: the time-traveling quasar. Located within the Leo cluster, this quasar has left scientists scratching their heads with its bizarre behavior. Unlike any other known quasar, this one appears to emit light from multiple time periods simultaneously. Imagine looking at a single object and seeing snapshots of its past, present, and future all at once. How is this possible, and what does it mean for our understanding of space-time? Quasars are already some of the most energetic objects in the universe, powered by supermassive black holes at the centers of galaxies. They emit immense amounts of light and radiation, making them visible across vast cosmic distances. But the time-traveling quasar takes this to a whole new level. Observations reveal that its light seems to arrive at Earth from different points in time, as if the quasar is somehow broadcasting its history and future in real time. This defies our current understanding of how light travels through space and time. One possible explanation involves the concept of gravitational lensing, where the immense gravity of a massive object, like a galaxy or black hole, bends the light from a more distant object. In this case, the light from the quasar might be taking multiple paths around a massive object, each path representing a different point in time. This could create the illusion of light arriving from different eras. However, the time-traveling quasar's behavior is so extreme that even gravitational lensing struggles to fully explain it. Could there be another force at play, one that we haven't yet discovered? Another theory suggests that this quasar might be interacting with a region of space-time that's been warped in an unusual way. Einstein's theory of relativity tells us that massive objects can warp space-time. But what if this quasar is sitting at the edge of a cosmic anomaly, a place where space-time folds back on itself? This could create a scenario where light from different time periods converges, making it appear as though the quasar is emitting light from multiple eras at once. If true, this would challenge our fundamental understanding of how space-time operates. The implications of the time-traveling quasar are profound. If light can indeed traverse time in this way, it could open up entirely new avenues for studying the universe. We might be able to observe the past and future of cosmic objects in ways we never thought possible. But it also raises questions about the nature of time itself. Is time truly linear, or could it be more fluid and interconnected than we realize? The answers could reshape not only our understanding of the cosmos, but also our place within it. As we continue to unravel the mysteries of the time-traveling quasar, one thing is certain: it's a phenomenon that pushes the boundaries of our knowledge. What other secrets does the Leo cluster hold, and how will they challenge our understanding of the universe? The journey to uncover these answers is just beginning. Next, we'll explore another cosmic illusion, a phenomenon where galaxies in the Leo cluster appear to shift positions over time. What could be causing this strange behavior, and what does it reveal about the forces shaping our universe? Now, let's turn our attention to a phenomenon that plays tricks on our cosmic perception, the galactic mirage. In the Leo cluster, astronomers have observed galaxies that seem to shift their positions over time, as if they're dancing across the sky. This isn't just a trick of the eye, it's a real, measurable phenomenon that challenges our understanding of how galaxies move and interact in the universe. At first glance, this might seem like a simple case of gravitational lensing, where the light from distant galaxies is bent by the gravity of massive objects in between, like black holes or galaxy clusters. While gravitational lensing can distort the appearance of galaxies, the galactic mirage goes beyond what we'd expect from this effect. The shifts in position are more pronounced and occur over shorter timescales, leaving scientists puzzled about what could be causing such dramatic changes. One intriguing theory suggests that the Leo cluster might be home to an unseen cosmic structure, a massive, invisible object or a network of dark matter filaments. These hidden forces could be subtly tugging at the galaxies, causing them to appear as though they're moving in ways that defy conventional physics. If true, this would mean that the Leo cluster is not just a collection of visible galaxies, but also a hub of mysterious, unseen forces shaping their behavior. Another possibility is that we're witnessing the effects of space-time itself being warped in unexpected ways. Einstein's theory of relativity tells us that massive objects can bend space-time. But what if the Leo cluster contains regions where space-time is unusually dynamic? This could create a kind of cosmic funhouse mirror, where the positions of galaxies appear to shift as light travels through these warped regions. Such a scenario would not only explain the galactic mirage, but also open up new questions about the nature of space-time and its influence on the universe. The implications of this phenomenon are far-reaching. If galaxies can appear to move in ways that don't align with our current models, it could mean that our understanding of gravity, dark matter, and even the structure of the universe is incomplete. The galactic mirage serves as a reminder that the cosmos is full of surprises, and even the most familiar objects can behave in ways that challenge our assumptions. As we continue to study this phenomenon, one thing is clear: the Leo cluster is a treasure trove of cosmic mysteries. Each discovery pushes the boundaries of our knowledge and invites us to rethink what we know about the universe. What other illusions might be hiding in the depths of space, waiting to be uncovered? The answers could reshape our understanding of the cosmos in ways we can't yet imagine. Next, we'll venture into one of the most enigmatic regions of the Leo cluster, a place where no light from stars or galaxies can be detected. What lies in this endless night, and what secrets does it hold about the universe's boundaries? Now we journey into one of the most baffling corners of the Leo cluster, a place shrouded in absolute darkness. This region, known as the endless night, is a void unlike any other. Here, no light from stars or galaxies reaches our telescopes, creating a patch of space that seems to defy the very essence of the cosmos. What could cause such a profound absence of light, and what does it reveal about the universe's boundaries? At first, one might assume this is simply a cosmic void, a vast, empty space where galaxies are sparse. But the endless night is different. Even in typical voids, traces of light from distant stars or the faint glow of cosmic background radiation can be detected. In this region, however, there's nothing. It's as if the light itself has been swallowed whole, leaving behind a perfect blackness that challenges our understanding of space. One possibility is that this region is home to an extraordinary concentration of dark matter, so dense that it blocks all light from passing through. Dark matter, which doesn't emit or reflect light, could be acting like an invisible curtain, obscuring everything behind it. If true, this would suggest that dark matter isn't just a passive presence in the universe, but can actively shape the way we perceive it. Another theory points to the idea of a cosmic boundary, a place where the fabric of the universe itself might be fundamentally different. Could the endless night mark the edge of our observable universe, a point beyond which light cannot travel? If so, it would raise profound questions about what lies beyond. Is there more to the universe than we can see, or does it simply end here? These questions push the limits of our knowledge and invite us to rethink the very nature of existence. Some scientists have even speculated that this region could be a window into another dimension or a parallel universe. If space-time behaves differently here, it might create a barrier that light cannot cross, effectively cutting off our view. While this idea is highly speculative, it underscores the mystery of the endless night and the tantalizing possibilities it presents. The implications of this phenomenon are staggering. If the endless night represents a boundary or a barrier, it could redefine our understanding of the universe's structure. It might also hint at the existence of forces or dimensions we have yet to discover. For now, this region remains one of the most profound mysteries in the Leo cluster, a reminder that even in the vastness of space, there are still places where light cannot reach. As we conclude our exploration of the 25 unexplained phenomena in the Leo cluster, one thing is certain: the universe is far more mysterious and complex than we ever imagined. Each discovery challenges our assumptions and opens new doors to understanding. What other secrets lie hidden in the cosmos, waiting to be uncovered? The journey to find out is just beginning. Now, let's turn our attention back to one of the most enigmatic phenomena we've encountered, the phantom galaxy. This mysterious galaxy, which seems to vanish and reappear in telescopic observations, continues to baffle astronomers and challenge our understanding of the cosmos. What makes this galaxy so elusive, and what secrets might it hold about the nature of dark matter and the structure of the universe? The phantom galaxy's erratic visibility is unlike anything else observed in the Leo cluster. One moment it appears as a faint, shimmering presence, and the next it's gone, as if it never existed. This behavior has led scientists to propose a range of theories, each more intriguing than the last. One leading hypothesis suggests that the galaxy's visibility is tied to the presence of dark matter. Dark matter, which makes up a significant portion of the universe's mass, doesn't emit or reflect light, making it invisible to traditional telescopes. In the case of the phantom galaxy, it's possible that dense clumps of dark matter are periodically obscuring our view, causing the galaxy to seemingly disappear. Another theory points to the possibility of gravitational lensing on an unprecedented scale. Gravitational lensing occurs when the gravity of a massive object, like a galaxy or a black hole, bends the light from objects behind it, creating distortions or magnifications. In the phantom galaxy's case, it's possible that an unseen massive object is intermittently bending its light away from our telescopes, making it appear and vanish at random intervals. This would not only explain its erratic visibility, but also hint at the presence of hidden cosmic structures we have yet to detect. Recent advancements in observational technology have allowed scientists to study the phantom galaxy in greater detail. Using radio telescopes and other instruments that can detect wavelengths beyond visible light, researchers have begun to piece together a clearer picture of this elusive galaxy. These observations suggest that the phantom galaxy may be surrounded by a vast halo of gas and dust, which could be interacting with dark matter in ways we don't yet fully understand. This halo might be responsible for the galaxy's flickering appearance, as it alternately absorbs and emits light in unpredictable patterns. The implications of these findings are profound. If the phantom galaxy's behavior is indeed linked to dark matter or gravitational lensing, it could provide crucial insights into these elusive aspects of the universe. Dark matter, in particular, remains one of the greatest mysteries in modern astrophysics. Understanding how it interacts with visible matter, as suggested by the phantom galaxy's behavior, could bring us closer to unraveling its true nature. As research continues, the phantom galaxy remains a tantalizing puzzle, one that challenges our assumptions and pushes the boundaries of our knowledge. It serves as a reminder that even in a universe as vast and seemingly knowable as ours, there are still phenomena that defy explanation. What other secrets might this ghostly galaxy hold, and what could it teach us about the hidden forces shaping the cosmos? The answers, much like the phantom galaxy itself, remain just out of reach for now. Now, let's shift our focus to another captivating mystery in the Leo cluster, the whispering black hole. This supermassive black hole has been emitting rhythmic radio signals that defy our current understanding of black hole behavior. Unlike the chaotic and unpredictable emissions typically associated with black holes, these signals are eerily consistent, almost like a cosmic heartbeat. What could be causing this strange phenomenon, and what does it reveal about the nature of black holes? One of the leading theories suggests that the rhythmic signals might be linked to the black hole's accretion disk, the swirling ring of gas and dust that spirals into it. As material from the disk falls into the black hole, it heats up and emits radiation. In the case of the whispering black hole, scientists believe that the disk might be pulsating in a regular pattern, creating the rhythmic signals we detect. This pulsation could be caused by instabilities in the disk or interactions with magnetic fields, though the exact mechanism remains unclear. Another intriguing possibility is that the signals are being produced by a companion object orbiting the black hole. If a star or another black hole is circling nearby, its gravitational pull could periodically disrupt the accretion disk, causing bursts of radiation at regular intervals. This would explain the rhythmic nature of the signals, but it also raises questions about how such a system formed and why it's so rare. Observations using advanced telescopes have yet to confirm the presence of a companion object, leaving this theory in the realm of speculation for now. Recent studies have also explored the idea that the signals might be a form of echo mapping. In this scenario, the rhythmic pulses are echoes of light bouncing off structures near the black hole, such as clouds of gas or dust. By analyzing the timing and intensity of these echoes, scientists hope to map the environment around the black hole in unprecedented detail. This technique could provide new insights into the dynamics of black hole systems and the behavior of matter under extreme conditions. The implications of these findings are significant. If the rhythmic signals are indeed tied to the black hole's accretion disk or a companion object, they could offer a new way to study the physics of black holes. Understanding how these signals are generated could shed light on the processes that govern the growth and evolution of supermassive black holes, as well as their impact on surrounding galaxies. It could also help us refine our models of how black holes interact with their environments, a key area of research in modern astrophysics. As scientists continue to study the whispering black hole, they are using a combination of ground-based and space-based observatories to gather more data. These efforts are complemented by advanced computer simulations that model the complex physics at play. While many questions remain unanswered, the rhythmic signals from this black hole serve as a reminder of how much we still have to learn about these enigmatic objects. What other secrets might the whispering black hole hold? And how will its signals shape our understanding of the universe? The answers, much like the signals themselves, are still unfolding. Now, let's unravel another layer of the Leo cluster's mysteries by diving into the enigmatic cosmic web. This vast, intricate network of filaments connects galaxies across the universe, acting as the scaffolding upon which the cosmos is built. In the Leo cluster, the cosmic web is particularly striking, offering a unique window into the large-scale structure of the universe. But what exactly is the cosmic web, and why is it so crucial to our understanding of the cosmos? The cosmic web is made up of dark matter and gas, forming a spider-like network that stretches across billions of light years. Galaxies, including those in the Leo cluster, are nestled within these filaments like pearls strung along an invisible thread. This structure is thought to have formed shortly after the Big Bang, as tiny fluctuations in the density of matter grew over time, pulled together by gravity. The result is a cosmic tapestry that shapes the distribution of galaxies and influences their evolution. Recent observations of the Leo cluster have revealed fascinating details about the cosmic web in this region. Using advanced telescopes and simulations, scientists have mapped the filaments with unprecedented precision. These studies show that the web is not just a passive framework but an active participant in the life of galaxies. For instance, the filaments funnel gas into galaxies, fueling star formation and driving the growth of supermassive black holes. This process, known as cosmic accretion, is a key factor in how galaxies evolve over billions of years. One of the most intriguing discoveries in the Leo cluster is the presence of filamentary galaxies, galaxies that appear to be stretched along the cosmic web's filaments. These galaxies are often sites of intense star formation, as the gas flowing through the filaments provides a steady supply of raw material. This phenomenon challenges our traditional view of galaxies as isolated islands in space, highlighting the interconnected nature of the universe. Another mystery surrounding the cosmic web is the role of dark energy. While dark matter provides the gravitational glue that holds the web together, dark energy is thought to be driving the accelerated expansion of the universe. In the Leo cluster, scientists are studying how these two forces interact, shaping the web's structure and influencing the fate of galaxies. Some theories suggest that dark energy could eventually cause the cosmic web to stretch and thin out, altering the way galaxies are distributed in the distant future. The cosmic web also plays a crucial role in the distribution of the universe's missing baryonic matter, ordinary matter, that has so far eluded detection. Observations in the Leo cluster suggest that a significant portion of this matter resides in the warm hot gas within the filaments. By studying this gas, scientists hope to solve one of the biggest puzzles in cosmology: where is all the missing matter in the universe? As we continue to explore the cosmic web in the Leo cluster, new questions arise. How do the filaments influence the formation of galaxy clusters? What role do magnetic fields play in shaping the web's structure? And how does the cosmic web interact with other large-scale phenomena, such as voids and superclusters? Each discovery brings us closer to understanding the universe's grand design. The cosmic web is more than just a cosmic curiosity. It's a fundamental part of the universe's architecture. By studying it in the Leo cluster, we gain insights into the forces that shape galaxies, the distribution of matter, and the evolution of the cosmos itself. What other secrets does this vast network hold, and how will they reshape our understanding of the universe? The answers lie hidden in the threads of the cosmic web, waiting to be unraveled. As we bring our journey through the Leo cluster to a close, it's clear that this region of space is a treasure trove of cosmic mysteries. From the vanishing phantom galaxy to the rhythmic whispers of a supermassive black hole, and from the glowing void to the synchronized dance of stars, each phenomenon challenges our understanding of the universe. These 25 unexplained mysteries not only captivate our imagination, but also push the boundaries of astronomy, forcing us to rethink what we know about dark matter, dark energy, and the very fabric of space-time. The Leo cluster serves as a reminder that the universe is far more complex and enigmatic than we often assume. Every discovery, whether it's the ghostly nebula detected only through invisible wavelengths or the rogue planets defying formation models, adds another piece to the cosmic puzzle. These phenomena aren't just curiosities, they're clues that could unlock the secrets of the universe's origins, evolution, and ultimate fate. As we continue to explore the Leo cluster and beyond, one thing is certain: the more we learn, the more questions arise. What lies beyond the endless night of the starless void? Could the cosmic web hold the key to understanding the universe's missing matter? And what other mysteries are waiting to be uncovered in the depths of space? The Leo cluster invites us to look up and wonder, to question and to dream. It reminds us that the universe is a place of infinite possibilities, where every discovery brings us closer to understanding our place in the cosmos. So, what do you think lies hidden in the Leo cluster's deepest mysteries? Share your thoughts in the comments below, and don't forget to like, subscribe, and hit the notification bell to join us as we continue exploring the wonders of the universe. Until next time, keep looking up. The stars have so much more to reveal.